In this video, we are going to see that how we are going to solve the solution of first order differential equation and also solving the linear differential equation using the method of integrating factor. Here the standard form of the equation will be like this: y dash e minus, or here can be plus, any sign can be here. P of t will be any function multiplied by y equals to g of t. So g of t is another function that is depending on independent variable t, and p of t also, it is an dependent variable or the function which is depending on the variable t. So here we have to see first of all, if the differential equation is given, the coefficient of y dash must be equals to 1. If it is not equals to 1, then we have to make it 1 by dividing the each term by that coefficient. We will do one question. Question number 1, finding the solution of the differential equation like y dash minus 2y equals to 3 into e power t. How to solve this differential equation? First, we are going to compare the given equation with the standard form of the equation. So the standard form is like this: y dash minus p of t. It can be plus or minus y equals to g of t. Now here we are going to see what is this function p of t and g of t. Now in this equation, the p of t is this one, minus 2. And here the g of t function is 3 into e power t. So first we will define that, and we will see firstly also the coefficient of y dash must be 1. In this equation it is already 1, so no need to divide with any uh, any of the term. Okay, so we are going to see the second, we will compute the integrating factor. To find the integrating factor, the formula is mu of t equals to e power p of t dt. And we are going to integrate this p of t function with respect to dt. Now, here the p of t function is minus 2, and we are going to integrate with respect to t dt. So we are going to see that minus 2t, we will get e power minus 2t will be our integrating factor. So whatever the integrating factor we get, we are going to just multiply the given equation with that integrating factor, the right hand side and the left hand side. So when we multiply this with the integrating factor, so we will multiply each term with the integrating factor, and on this side always it will be the derivative of the integrating factor multiplied by 1. So it is always will be like this. Okay, so always we are going to write a d by dt and multiply the integrating factor with the y. And on the right hand side also, we are going to multiply the function q of t multiplied by the integrating factor. So here e power minus 2t is the integrating factor, and et was the function q of t. So et is already there as a function q of t. So when they are multiplying, so we are going to add the power. So we get minus 2t plus t, we will get minus t. And again now we are going to just rearrange, dt will be coming here and d will be on this side, so integrate both sides. And then we are going to get, after integration, on this side we get e power minus 2ty, and on this side when we integrate, e power minus t will be the integration will be e power minus t over minus 1 plus the constant of integration. After that, we have to find the solution. Y equals to whatever the terms will be on the right hand side. So we will divide each term by e power 2t here also and c also. So we divide each term so that we can get the solution. Y equals to, so we get in the end y equals to minus 3 e power minus t plus 2t, minus 3 plus 2t will also be equals to t. And here also plus c, for c this we will take it to the numerator, so we will get c into e power 2t. So we get y equals to c into e power 2t plus minus 3 into e power t. So this will be the solution of the given differential equation. And then if you want to check that the solution of the given differential equation is correct, you can just take the derivative of this solution. We can give in the given equation, we can just substitute the value of this solution in the given equation. If it is satisfied, then we can say that our solution is correct. So in order to check, this is for checking that we will take the first derivative and just we are having the first derivative. So we'll take the first derivative of this each term. So we get 2c e power 2t minus 3 into e power t. Okay, so take the derivative and substitute in the given equation. If we substitute in the given equation and it is satisfied that both sides, left hand side is equals to right hand side, then it shows that our solution is correct. So this is how we can check our solution. And second is question number 1. Find the solution of the differential equation y dash plus y equals to 5 sine of t. Here also we are going to first compare this equation with the standard form of equation. So the standard form is y dash plus or minus p of t y equals to g of t. Here will be y, the coefficient of y dash must be 1. So it is already 1. So we will not divide with any term. So in this p of t function is just 1 because the coefficient of y is 1 and g of t is 5 sine 2t. The second we are going to compute that how to find the integrating factor. The formula is e into the power of p of t dt. And here p of t is just 1. So we will get the integrating factor as e power t. So we will multiply this integrating factor with the given equation, each term of the given equation, and then we will simplify. So after multiplying each term with the integrating factor on the left hand side and on the right hand side, we will rearrange as d by dt. So this is actually we can also write as d by dt of integrating factor multiplied by y. And on this side we just multiply the function q of t, or here is g of t multiplied by the integrating factor. After that we keep this d on this side and dt we can take it to the other side, and after that we will integrate both sides. After integrating on the left hand side we get e power ty, and on this side we can take 5 out of the integration, it is constant, but inside we will have e power t into sine 2t. So here we can see these are the this is the product of two functions. So here we can apply the tabular integrations because they are two functions. So for we will take the derivatives and integrals of two functions. So on in the derivative side we will take sine 2t, and on the integral side we are going to take the e power t. So here we already know that we apply here the LIATE rule. So the same we are applying here for derivative and integrals. So after that we will take the derivative of sine 2t. It will be 2 into cos 2t, and the derivative of cos 2t will be again minus 2 into 2 4 sine 2t. And again we are going to see that they are not going to come to 0 because e power t integral is e power t, so it is same. So 0 is will not be coming. So when we are going to stop, if we are having such integral, then we will see that whenever we get the same function where we started. So when we started, the function is e power t sine of 2t. So here also we can see e power t sine of 2t. Regarding this coefficient and the sign, it doesn't matter. Okay? But if the function is same, other than regarding we are not going to regard the sign. Okay, sign and this coefficient doesn't matter. But if the function we get the same as we started, so we are going to stop it over there. Otherwise this function will never stop. So after this we are going to then just rewrite that we are going to write e power t into sine 2t with a plus sign, and here we will write minus sign 2 into cos t into e power t, and here we are going to write the integral of these two multiples. So in the next step we are just writing all this again, and we are going to find this integral, and we will write down in this form what we get from this tabular integration, and after that we will try to simplify. And this also we have started this integral with the function, so this is we are replacing it with I, that we started this function with the integrations. So after that we are going to get e power t sine 2t minus 2 into e power t cos 2t minus 4i. This 4i we can take it to this side, okay, minus 4i, it becomes plus 4i, and on this side we will left with these terms. So plus 4i plus I, we will get 5i, and on this side we get the same uh, terms. After that we just divide this all by 5 so that we can get rid of this 5. So we will divide each term by 5, and then after that we substitute this I in the A. So where we started, we name that equation as A. Okay, so we will substitute this I with whatever the integral we get. Okay, so here this is our I, and we are going to substitute in the equation A, and then we are going to get this as a e power t y equals to, thus 5 and 5 will going to be cancelled out, and in the end we are going to divide each term by e power t so that we can get rid of this e power t on this side, so that we can get the solution of y equals to sine 2t minus 2 into cos 2t plus c into e power minus t. Okay, so here should be c also. Okay, and c also is a constant of integration, and this is the solution of the given differential equation. So find the solution of the given initial value problem. Now here initial conditions are given that after finding the solution, we will find the value of c by substituting these initial condition. Y of minus 1 equals to 0. So here we are going to see that this is the given equation, t cube into y dash plus 4t square y equals to power minus t. So here the coefficient first we will see, is it 1? So here now the coefficient is not equals to 1. So we are going to divide each term by 3, t power 3, okay, or t cube. So coefficient is not equals to 1. So we divide each term by t cube, and then we are going to simplify them. And after that we can see, now we can compare the equation with the standard form, that what is p of t and what is this g of t. Okay, so here we can see p of t is 4 over t and g of t is e power minus t and t power over t power cube. Okay, so second we are going to compute the integrating factor here. So p of t is t over 4. Okay, 4 we can take it out. So 1 over t dt means this is the ln, or to integrate 1 over t dt will be the ln of t, and this is also again the ln property. We can take this 4 coefficient as a power so that we can cancel this e and ln. So we get t power 4, and mu of t equals to t power 4. Okay, so here third we are going to apply the equation 1 by integrating factor. So we will multiply each term by integrating factor, that is t power 4. Here also on the right hand side t power 4. So multiply each term. So this and this will cancel. Here we left with just t, and on this side we are going to, we can write this as integrating factor multiplied by y. Okay, always this is the rule, that this will be the derivative of integrating factor multiplied by y. And after that we are going to just take this dt on this side and integrate both sides. And for the integral also, this and this will be cancelled out, integral and derivative, so we left with t power 4y. But on this side again, this is the product of two functions, so we will use the tabular integration. And for the tabular, for integral we are going to select e power minus t, and for the derivative, this is a polynomial, so we are going to select, for derivative we will select t. So t's derivative is 1, 1's derivative is 0, but for this one we will always have uh, the same, but just with the plus and minus signs, the e power minus t. So here we get 0, so we stop it over here and then multiply these two uh, terms and plus and minus sign. So in the end we will get the integral like minus t e power minus t and minus e power minus t plus c, and we will get rid of this t power 4. So divide each term by t power 4 here and apply the initial condition as now to find the value of this c, constant of integration. So initial conditions are y minus 1 equals to 0, that y is 0 and this t is minus 1 here. So substitute t is equals to minus 1 here, or here everywhere wherever is t, we will substitute as -1. Okay, so when we substitute them, so we will get the values, or we can see here the what are the initial conditions. Okay, -1. So here is -1, so minus and minus becomes plus. Here also it becomes plus. Here also we will get what? -1, but minus into -1 becomes +1. Here also +1, but here will be minus. Okay, so just substitute wherever is t, we will substitute with -1, and on this side it will be 0, y is 0. So in the end this e's will be cancelled, plus e and minus e, so c will be equals to 0. And then substituting this value of c in the equation number 2, which was our solution, so we will write down as y equals to minus e power minus t over t cube and minus e power minus t over t power 4. And this is the required solution of the given initial value problem. So this is how we are going to solve the first order differential equation using the method of integrating factor method. Okay, and here just we can see that just we can uh, put here as that this sign will be just plus. Okay, there can be plus sign. There is no need to write here minus in the standard form. And also wherever is p of t will be just whatever the function is given. Okay, so in the standard form here will be plus. Okay, this. So that's all. Thank you so much for watching.